All right, our goal and our objective for this video is to discuss and solve some problems using our natural base of functions. And as we've already gone over in class, we know that the natural base of functions is our base e. And we know that that base e is our Euler's number, as we've already gone over in class. All right, so now we're just going to go ahead and do some problems using Euler's number. And these functions are useful for describing continuous growth or decay. And the key word there is continuous. So it means it's constantly growing or constantly decaying. Something that we've gone over in class already. All right, so up to this point, we've only worked with rational bases, meaning bases that can be expressed in the form of a fraction, but now we're going to talk about irrational bases, and that's where we get the letter e, as we've already discussed. So y is equal to 1 plus 1 over x raised to the x power, where x tells us how often we are going to be compounding our interest, whether daily, weekly, monthly, and this can be regarded as y is equal to e, and e is Euler's number. All right, and this is this little chart that shows you how you can get that number, something that we've already discussed. All right, so now let's go ahead and solve some problems using this. All right, the first problem is just going to be using a graphing calculator to evaluate Euler's number, or to evaluate our base e raised to a power. So we will just go to where we would do our regular math. And then if you look here where it says ln, there is a button in yellow that says e to the x power. So that means we got to press shift, ln, and now it's e raised to a power. So if we want to evaluate e to the third power, we just press 3, we press execute, and there is our answer. All right, so it's pretty simple, but you might have never used that number before, so it's just going over where it is located on your calculator. All right, so since it's written in orange, we need to know that we need to press shift, so that way we're using all of our orange buttons. We press ln, it then raises it to the power, and then whatever we want, type it in, press enter. All right, that's it for using it for a calculator, and then there's a few more things that we're going to do. All right, so for this one, it's going to be solving a problem where we're going to be compounding something continuously. All right, so before we've gone over where we compound it annually in section 7.1, and then in class the other day, we've gone over when we compound it daily, weekly, monthly. So we've gone over all these different examples, and we know when we compound something continuously, we're using the base e. So when we're compounding continuously, we need to use our number e. All right, and then the formula for when we're compounding something continuously is our a sub t is equal to p times e to the rt power. And remember, our a sub t is our amount after we have gone ahead and compounded continuously or quarterly or whatever it is. Our P is our principal or our starting amount, so how much we started with. Our R is going to be our interest rate, and then our T is time. And remember, E is our Euler's number. All right, so one of the problems that we might have is, suppose you won a scholarship contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. So this is something you need to look for. Remember, we need to know how much we're compounded. So when it's compounded continuously, we know that we're going to use our base E. And then it says, how much will you have in the account when you enter high school 4 years later? Express the answer to the nearest dollar. So we know our A sub t, that's our final amount, is equal to P times e to the RT power. All right, so now we need to go ahead and substitute everything that we know. So our principal, or our starting amount, was $3,000 because that's what was deposited. So I know that P is equal to 3,000. Our interest rate, our R, they tell us it's 5% interest rate. So we know that our R is going to be equal to 5%, which as a decimal we know is equal to 0.05. And then the last thing, T in time, it says that it is going to be 4 years later. So we know that our T is equal to 4. So our equation to find our final answer, how much we have after 4 years, it'll be 3,000 times e to the 0.05 times 4 power. All right, so now we just need to go ahead and plug this into a calculator. So it'll be 3,000 times shift ln, so we get our e, our Euler's number. And now it's important that you put this in parentheses, because if you don't put it in parentheses, it's only going to raise e to the 0.05 power and not 0.05 times 4. All right? So that means after 3 years, or after 4 years, you would roughly have $3,664.21. So our answer to this will be approximately $3,664.21. So you would earn roughly $664 more than what you put in. Right, and that's it for this section. So just a real quick one going over Euler's number. We've already have already done some of this in class before, and that's it.